Hello there, welcome to this video on degrees and radians. In this video, we are going to talk about how do we go from what we've known as angles in degree measurement to a whole new type of measurement called radians. And radians really is the foundational component of working with trigonometry and kind of breaking into concepts such as the unit circle, which this unit is all about. Okay, so let's go ahead and look at this idea. So you guys know from earlier learning that an angle of 180 degrees makes a straight line. Okay, and it is also possible to have angles that are greater than 180s, and believe it or not, you can actually have negative angles. Let's talk about an angle what's in standard position. So if I have an angle in standard position, forgive me, trying to figure this. Okay, if I have an angle in standard position and its vertex is at the origin, okay, so that means it's right here. So here's what it is. Its initial side is on the positive x-axis, okay, and that's this right here. Here's the initial side. The terminal side, okay, so that's important. Initial side on the positive x-axis, and the terminal side is where it ends. So here's the terminal side. Okay, terminal, right? Meaning where it ends. And it can be in any single quadrant, so I can end that angle wherever. Okay, so that is an angle in standard position. An angle is positive if it is measured in a counterclockwise direction, meaning here is my initial side, and it goes in a counterclockwise direction where it ends. If I go in the opposite direction, if I go clockwise, that's actually a negative angle measure, and we're not going to cover that in this curriculum. I want to talk to you guys about what a quadrantal angle is. First of all, I want you to say quadrantal. Can you say quad? Like your quadricep, quad, meaning four, right? Quadrantal. Okay, and that is an angle in standard position where its terminal side is on an axis, right? It ends effectively at the end of a quadrant. Okay, and here's some examples of it: 0 degrees, a 90-degree angle, 180-degree angle, 270, and 360. Those are all quadrantals. Okay, first revolution, positive quadrantal angles in degree measures. And again, we kind of just saw them. So quadrant 1, the quadrantal will end at a 90-degree angle. Okay, in quadrant 2, that quadrantal angle, if it ends at the end of quadrant 2, would be 180 degrees. If you go all the way through quadrant 3, that's 270, and then all the way back around is 360, which is the same as 0. Okay. All right, so let's go ahead and draw some angles, okay? And they want the angle in standard position. So remember, its vertex is at the origin, and I have an initial side, which is here on the positive x-axis, okay? So that's where it starts, and I want 135 degrees. So I'm going to go ahead and go this far, right? I'm going to make a little arc, okay? That's 90 degrees. We know that that's 90. And then you know, if I go ahead and subtract 90 here, I need to go another 45 degrees into this quadrant. So I go here, and there is my 135 degree angle. Pretty simple, right? Okay, let's go ahead and do 210. So again, here's my initial side. Initial, right, meaning starting, right? Initials. Come on, spell, Schwarberg. Initial side. I blame my math education on not being able to spell. So there's your initial side. Okay, I'm going to go all the way to here. This is 180 degrees, right? And if I take away 180, I have to go another 30 degrees into this quadrant, which is about here. Okay, and then where it ends, again, remember, is its terminal side. I have to like phonetically sound these out. Not 180, 210. Okay? All right, so that's drawing an angle in standard position. Here are some practice problems. Please go ahead and try these. Pause the video, and I'll show you the answers in a second. All right, hopefully you paused them. Here are the solutions. Did you get those? You did? I'm so proud of you. Good job. 300 degrees, right? You're going to go 270 and about 30 degrees more into that quadrant. And then 120, that's 90 plus 30, right? So that's how I kind of break them up. I use those quadrantals to break them up and kind of know, where they should be. Okay, so here's where we're going to explore this idea of radians. And I want you to be able to say that, radians, right? It's a pretty rad word. Did you get that? Rad, like radiant, rad. I know, okay, I'm a dad and a math teacher, right? I've got lots of problems. Math problems. All right, sorry, I'll stop. Okay, the concept of degrees is based on dividing a circle into 360 equal sectors, and each sector is equal to 1 degree. So that's kind of where degrees come from. But there's a problem with degrees. I can't do calculations with degrees. They're not a real number. Okay, so what we have to do is we have to come up with something else, another way to measure an angle. And that is where we come up with radians. Now, the radian measure, okay, so the radian measure of an angle is the real number measure that is equal to the length of the arc subtended by the angle in the circle with a radius of 1 unit. So this is kind of like where the idea of a radian is coming from. You don't really need to know that. It's just, that's kind of how we get this value, okay? So let's talk about how we go from degrees to radians. And I'm going to start with the idea of the circumference of a circle, meaning the perimeter, right, the outside of a circle. So you guys learned in middle school that the circumference is equal to 2 pi times the radius. Well, what we use is a radius of 1 unit. So this distance right here is 1 unit. So if I substitute that into the formula, we get the circumference is 2 pi. Okay, so 360 degrees, if I go all the way around the circle, right, that's 360. Okay, in radians, that would be 2 pi. So here you get a conversion ratio. Okay, 360 is equal to 2 pi radians, right? And tapping into your chemistry knowledge, if we're talking about conversion, so I have this kind of ratio. 2 pi radians is 360. And you know what? In math, we love to simplify, so we get this, pi radians over 180. So that's our conversion ratio, and that's very, very important, okay? And what we're going to do is we're going to go back and forth between degrees and radians and degrees, back and forth. Okay, this whole unit, we're going to do a lot of this. So this is very, very important, okay? So I want you to note, if I'm going from degrees to radians, right? I want to get rid of the radians. I'm going to divide by, I'm going to get rid of the degrees, and I'm going to divide by them. And I want to multiply by radians because I want radians. So radians is on top. Okay? Whereas over here, right, if I have radians, I want to divide by radians. And then I want to go to degrees. Okay, so I put the degrees on top. Okay, and this is very, very important. Beautiful star. 180 over pi. Pi, 180. Right? There's like a TikTok out right now. It's like, man, I don't know how to find pi. And then there's that song, I did a full 180. Okay, remember that. It's stuck in my head every time I hear it. I'm like, there's pi. All right. So let's go ahead and put this into practice. How do I convert each degree measure to radians and then vice versa? Radian measures to degrees. Okay, let me grab a pen real quick. So I have 135 degrees. I want to get rid of degrees. So I'm going to put 180 degrees on the bottom, just like that. And I'm going to put pi radians on top. And sometimes you'll see this too. They'll do this pi rad, or maybe sometimes you'll see just a pi and then like a little r up there to tell you it's radians. Generally, when you see a pi, it's in radians. Okay, so I have this, but what I want to do now is I want to go ahead and reduce. 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 Okay, so I'm going to reduce. Generally, these angles will reduce by 30 degrees, 45 degrees, or 60 degrees. Okay, and those angles are significant. They'll come into play later on, but that's what we'll reduce by. So if looking at this angle, 135 and 180, I am going to reduce by 45 degrees. By 45. Reduce by, well, I'm reducing by 45. Okay, so this ends up being 3, this ends up being 4. Now, how did I know that? Well, just looking at those, I mean, I kind of know this, but it ends in a 5. So therefore, it's going to be divisible by 5, right? That's divisibility rules. So that's how I get that, okay? So this ends up being 3 pi over 4. Now, and if you didn't know that, you could just go ahead, you could divide by 5 right away. You could break it down, and then you'd end up maybe dividing by 3 and then divide by 3 again, okay? Which would be reducing by 45, okay? All right, let's go ahead and do the next one. Let me switch back to red so then I can reduce. Okay, divide by 180 because I want to get rid of the degrees, and I'm going to multiply by pi. Okay, so this one has a 0, so it's going to be like a 30 or a 60 reducing. And I'm just using my brain. 57 is not reducible by 6 because it would have 60 is reducible by 6. So I know this is going to be reducible by 30. So if I reduce this and reduce this, this gives me 19. And down here, I get 6. So the answer is 19 pi over 6. All right, so that's going from degrees to radians. And notice how I didn't plug in a calculator. Do not use a calculator and just plug this in and get a decimal value. That's not the point. You're supposed to reduce using your brain. I guess you could use a calculator to reduce if you needed to, but I mean, come on, you're better than this. Okay, so next, let's go from radians to degrees. So I'm going to get rid of radians, pi radians, and then I want to multiply by 180 degrees. Okay, so what cancels? Well, my pi's reduce, and then the 6 reduces with 180. This is 30. So I have 5 times 30, which is 150 degrees. Simple. Next one, 9 pi over 4. I'm going to divide by pi to get rid of the pi. And I want to introduce degrees, so I put 180 on top. Okay, the pi's cancel. I'm going to reduce the 4 with the 180. This turns into 45. And 9 times 45, well, 10 times 45 would be 450. So 1 less, it's 405 degrees. All right, so that is converting from degrees to radians. Here are some practice problems. Please go ahead, pause the video. I want you to try these. All right, hopefully you have paused the video. Here is the solution. Okay, so 20 degrees over 180. Hey, that's 1/9, right? Pi ninths. And then 420 degrees. If I convert that, that ends up being 7 pi over 3. That one was reducible by 60. Okay, and then the next one's 225 and 210 degrees for your answers. All right, so the last topic that we're going to talk about is graphing in radian measure. So if I take this idea, right, we knew that 180 degrees is this quadrantal, right? So that's pi. And if I cut that in half, then that's pi over 2, right? That's the same thing as 90 degrees. Okay, and if here I have pi over 2, this is kind of like 2 pi over 2, which reduces to pi, which this becomes 3 pi over 2 at the bottom, this quadrantal. And then over here, this would be 4 pi over 2, and that reduces to 2 pi. Okay, so you get these quadrantals, pi halves, pi, 3 pi over 2, and 2 pi. So let's go ahead and graph some angles. Okay, so they want us to draw each angle in standard position. Pi divided by 3. Well, I know, okay, here's my initial side. I know that this is pi, but I don't want pi. I want 1/3 of pi. So if think about like splitting it into thirds, right? I only want this much. There's pi thirds. Okay, so I can erase. There's pi thirds. All right, 5 pi over 4. Okay, well, I know that this is pi, and if I look at the denominator, it's 4. I want this denominator to be 4, so to be pi, it's 4 pi over 4. Okay, so here's my initial side. 4 pi over 4. Now I want 1/4 more. I want it to be 5 pi over 4, okay? And that's going to be here, right? So 5 pi over 4, right there. And there you have it. Okay. Here is some practice problems. Please pause the video. I want you to go ahead and graph these. All right, hopefully you have paused them. Here is the solution. 5 pi 6, that's just 1 pi 6 short of pi. Okay, and then 7 pi fourths, that's just 1 pi fourths short of 2 pi. All right, so that is it. I have introduced you to degrees going to radians, and then how to graph an angle in standard position. Okay, catch you next time. Peace.